Good morning, students. Today I am going to take up some numericals on the topic of equivalent resistance. Now, let me take up the first example. If you look at the diagram here, this is the first numerical we are going to take up. And this is 6 ohm, this is 2 ohm, this is 3 ohm. Now, when the current is coming at this point, it is divided into two branches. Now, since the current has been broken up into two parts, that means the two resistance 2 ohm and 3 ohm are connected in parallel. So as you can see the circuit here, the current is passing through 6 ohm. After reaching at this point, it is divided into two parts, and these two parts are connected in parallel. So now, since they are connected in parallel, for resistors of 2 ohm and 3 ohm in parallel, the equivalent resistance Rp, we are assuming the equivalent resistance of 2 and 3 as Rp, and the formula we are knowing that 1 by Rp is equal to 1 by 2 plus 1 by 3, that is going to give us 5 by 6. But our motive is to find out the value of the Rp. So what we are going to do, we will do the reciprocal of it, and that is going to come as 1.2. So the equivalent resistance of this branch, which is in parallel, is coming to be 1.2. Now, this Rp, that is 1.2, and the 6 ohm, they are connected in series because the same current is passing through 6 ohm and through the 1.2 ohm. So when the same current passes through two resistors, they are assumed to be connected in series. And so, according to the diagram, the resistors of 6 ohm and 1.2 ohm are in series. Therefore, the total resistance of the arrangement can be obtained by the formula, that is, we will add up both the values, 6 plus 1.2, that is 7.2 ohm. So if you look at the question here, in the diagram first, we have solved this part which was in parallel. We got the equivalent resistance of this branch. Now this equivalent resistance and this 6 ohm are connected in series because the same amount of current was passing through both of them. And when same amount of current passes through both the resistors, they are assumed to be connected in series. So the total resistance of the arrangement is coming to be 7.2 ohm. Now let me take one more example here. We have a diagram here. The current is coming here. After coming here, it is divided into two branches. This is the top branch, which contains two resistors of 6 ohm and 6 ohm each, and at the bottom we've got another 6 ohm. So R1 is 6 ohm, R2 is 6 ohm, and R3 is also 6 ohm. Now once the current reaches to this junction, it is branched into two parts. So I can say the top branch and the bottom branch are connected in parallel because there is division of current at this point. Now when the current reaches on the top branch, it is passing through both the resistors R1 and R2. Now these are connected in series because the same amount of current is flowing through R1 and R2. So once we are going to solve this circuit, we have to first solve the upper branch. So in the circuit, R1 and R2 are connected in series. The equivalent resistance of this combination will be coming as Rs is equal to 6 plus 6, that is 12 ohm. So since both of them are connected in series, we will first find out the equivalent resistance of R1 and R2, that is coming to be 12 ohm. Now that diagram is now simplified in this format. This is the value of RS, that is 12 ohm, and this is the value of R3, 6 ohm. Now if you look at the diagram here, at this point, since branching is taking place, so the 12 ohm and the 6 ohm are connected in parallel. So whenever we have branching of current, that will be considered as parallel, and whenever there is a continuous flow of current, it is assumed as series. So now since both of them are parallel, so RS and R3 are connected in parallel, so the equivalent resistance RP of the whole circuit can be given as 1 by RP is equal to 1 by 12 plus 1 by 6. Solving, it is going to give me 3 by 12. Now since I have to find the value of RP, I will go for the reciprocal it, and the ultimate answer is coming to be 4 ohm. So if you look at the diagram here, first we have solved the upper branch, which was coming to be in series. Then after we got the value of the upper branch, these two branches are parallel, and ultimately solving these two branches, we have got the answer as 4 ohm. Now coming towards the next type of question. Now let me take one more type of question here. Now in this, the current is coming here. This is R1 6 ohm, R2 6 ohm, R3 6 ohm, and R4 6 ohm. Now when the current is coming here, it is divided into two parts. So R1 and R2 are connected to each other in the form of parallel. The same thing is happening here also. The current is divided into two parts. So R3 and R4 are connected in parallel. So if we go for the solution, in the circuit, there are two parts. Part number 1, part number 2. Each part, two resistors are connected in parallel. That is, this and this are parallel, this and this are parallel. If the equivalent resistance of each part is Rp, I take up the equivalent resistance of this part at Rp as Rp, and the formula says 1 by Rp is equal to 1 by 6 plus 1 by 6, that is coming to be 2 by 6, and therefore Rp will be coming as 3 ohm. So it means that after I have solved the first branch with the help of parallel combination, I am going to get the equivalent resistance of this branch as 3 ohm. Same thing is going to happen here also, as they are also connected in parallel. So this is also going to give me 3 ohm. So if you look at the technique, first we have solved the first branch, then we have solved the another branch, and all solving, the two parts are now connected in series between the two endpoints. That means the first part is going to give me 3 ohm, the second part was going to give me 3 ohm, and as the same current is passing through both of them, that means these two are connected in series. Now as they are connected in series, we will get the total resistance by adding their value, that is coming to be 6 ohm. So if you look at the diagram once more, the technique is very simple. First, we are going to solve the first branch, and once we look at the branch, it is parallel combination. So we solved and we got the first part equivalent resistance, that is 3 ohm. The second part also was having parallel combination, which has given me again 3 ohm. Now the answer of the first part and the answer of the second part, they were connected in series. This is the diagram which is going to make it clear. Now since they are connected in series, we will add up both of them, and the total resistance is coming as 6 ohm. So this is the way we are going to solve some of the questions of the topic of equivalent resistance. So the thing which you have to keep in your mind while solving the numerical is that whenever there is branching of current, then we will use the concept of parallel. Whenever there is a continuous flow of current, we will use the concept of series. So this is the way we can solve the questions. In the next class, we will take up some more numericals based on this topic. So thank you. Before ending the class, I can only say that the assignment which I am going to give you will be based on these questions only. I hope you have understood it, and please try to solve the assignment. Thank you.